Okay, so next pro tip. If I just look at the two equations in general form, when it's all expanded out like that, it looks like a general form. Question is, how could I just look at it and go, hey, I've got hyperbolas? Is it also possible to look at it and go, oh, I have a horizontal versus a vertical transverse axis? So let's take a look, just like we've done before with the ellipses and the hyperbola, the parabolas. So if I look at that equation, I've got an x squared term. So the x squared term, of course, means that I have two zeros on the x-axis. The y squared means I have two zeros on the y-axis. And then I have a negative sign, and think of the negative sign as an inside-out ellipse. So I'm taking my ellipse and then turning it inside out. And I get the shape of a hyperbola. So if you think of things like that, I have both an x squared and a y squared, and they're subtracted. I have myself a hyperbola. Now, can I just look at this and say, oh, well, since the 3 was negative, and that's the y, this must be a horizontal transverse axis. If I look at the picture that goes with it, that's not always the case. And you'll see why in just a little while, whenever we go to put it into standard form and we end up dividing by the constant, sometimes the constant's a negative number, and when I divide both sides by a negative number, the ones that are on the left-hand side switch signs. So sometimes that's hard to tell. You can't tell until you actually do the math. Okay, so if I look at the second one, again, I've got two zeros on the x-axis. I've got two zeros on the y-axis because of x squared and a y squared. And the negative sign's indicating I have that inside-out ellipse. And so this time I have a positive x squared term, and so I would expect to have a horizontal transverse axis, and I do. But remember, it doesn't always work out that way. It doesn't always work out that way. So this is how I put it in from general form to standard form. Same thing that I did with the ellipse. The only complication is that you have a negative sign in there. So step number 1, group your x's together and your y's together and get the constant over to the other side. Get rid of it. Okay, and then step number 2 is separately you're going to complete the square on the x's and complete the squares on the y's. And then finally, so that the thing is equal to 1, you're going to divide both sides by the constant. Okay, same exact steps that we did with the ellipse. So let's try that on one final problem here. Actually, next to the last problem, but whatever. I think it's the next to the last one. Here, let me just take a sneak peek. Oh, there we go. So find all the relevant points of this hyperbola. And that's going to be easy if we first put it into standard form. So putting this thing into standard form goes like this. Got to group up the x's together. So 9x squared minus 36x. Now group up the y's together. Negative y squared minus 6y. And then get rid of the 18. And that should be a negative 18 because I subtracted it. Okay. Now we have to complete the square. When you complete the square, leading coefficient has to be a 1. So I got to factor out of 9 x squared minus 4x plus a blank. Close parentheses on that. Now notice that the y squared has a negative in front of it. I'm going to have to factor that out. So negative and then y squared plus 6y. So that sign changed because I factored out the negative plus blank equals negative 18 plus blank from the first one, but minus blank from the second one, right? We subtracted that number, or we will subtract that number. So I take half of the negative 4, 2 squared is 4, multiply here, and I get 36. So I got to add 36 to the right-hand side. Okay. Take half of the 6 and square it, so 3 squared is 9, but I didn't really add 9. I added negative 9, so I have to subtract the 9 over here. Okay, let's clean this up. 9 times x minus 2 squared minus y plus 3 squared is equal to, let's see, that would be 18. 18 minus 9 is another 9. Now I have to get rid of the constant by dividing everything, both sides of this, by 9. And I finally have x minus 2 squared over, I'm going to go ahead and put it over 1 so that we know what the a value is supposed to be, minus y plus 3 squared over 9 is equal to 1. So here's my equation in standard form. And now, let's find all of the relevant points. Relevant. And no, you can't just go, I think they're all irrelevant, so I don't have any points to find. That doesn't work. Anyway, I need a center point, so my center point is at 2, -3. All right. Down here at the bottom, I have a 1 underneath the x, which is positive in this case, so this is my a value. It's actually a squared, but since that's just 1, square root of 1 is 1. So that means the 9 must be b squared, and my b is equal to 3. So let's find next my vertices. My vertices, this is a horizontal transverse axis. Let's write that. Horizontal. How about that? That looks right. So that means that I'm going left-right from the center point. So I go 2, and I add 1 to it, so 3, -3. And I also subtract 1 from it, so 1, -3. Now I also need to do my vertices, or my foci. In order to do my foci, I need to get my c value. So I have to use the Pythagorean theorem on that. C is equal to the square root of a squared, which is 1, plus b squared, which is 9. That's the square root of 10. And that's on the same horizontal line as my vertices. So I'm going to start again at the center point for my foci, and I'm going to add square root of 10, add and subtract. So it's 2 plus or minus the square root of 10, -3. And there's all the relevant points for that hyperbola. One last example here. Okay, this one's a tough one. Let's see if we can handle it. Find the equation of the hyperbola with those two vertices and asymptotes at y equals that one and that one. Crazy. All right, so of course I need an a and a b value, and I need my center point. To get my center point, that part's easy. I just take the average of my two vertices, right? So the center, 3's aren't changing. Since the 3's aren't changing, the x values are staying the same, but the y values are changing. That's vertical, so I need to make note of that, vertical. So that means whenever I find my a, it's going to go underneath the y, and the y is going to be positive. So the center point is a 3, comma, I got -5 plus 1 over 2, that's -4 over 2, which is -2, 3, -2. Okay, there's my center point. I now need my a and my b. I can get my a from my vertices, right? Because the distance between those two is a transverse axis, which is 2a. So here I'm going 1 from 1 to -5. So 1 minus a -5, 1 plus 5 is 6. So a is equal to 3. But what about my b value? I think maybe what I need to do is kind of sketch a picture so I can get a hold of this information in a visual sense. So my two vertices, where are they? I've got 1, 2, 3, and -5. And one at 3, 1, which is right here. Okay, so there, what I just drew in there is my transverse, or my conjugate axis. Yes, transverse axis. All these terms getting totally confused, All right, like I said, that one is vertical. And my center point, I didn't put a dot for it, but it's right 3, -2. I need to move that down a spot, which is right there. Okay, now then, in order to graph my asymptotes, I'm going up a and over b. So up a over b, that's got to be the slope. The slope is equal to a over b. The slope of this line is equal to 2. I already have my a value, which is 3, so 3 over b must be equal to 2. Now just switch those things out, which means that b's got to be equal to 3/2. Ooh, a fractiony one. That's curious. All right, so we have our A value, our B value, and we have our center point. Let's put all this stuff together and find the equation. Now, we said that it was a vertical transverse axis. Vertical transverse axis means that the A value is going to go with the Y, and the Y is going to be positive, so we have to write that one down first. So Y, oh, see, I almost wrote this, minus 3, but I need to write the Y coordinate there. Yikes. Okay, so that's a plus 2, because that's the Y coordinates, minus K, squared over, and my A value is 3, so 3 squared is 9. Minus, now do the same thing for the X values, X minus 3 squared over, my B value is 3/2, so square that thing up and I get 9/4 equal to 1. A fraction within a fraction, complex fraction, crazy. So I will say this, and that is, your book may not have that with the fraction down at the bottom, so they might rewrite it like this. Since that's a complex fraction, you can simplify a complex fraction by multiplying by a reciprocal. I can take the 4 from down here and just put it up on the top, and then that equation would be equivalent. Just saying. All right, so that concludes Objective 2 about writing the equations of hyperbolas. Objective 3 is going to be about graphing them.